Hello, 11th graders. So we're getting closer and closer and closer to this thing called Voronoi diagrams. And in order to be able to make a Voronoi diagram, which you are going to be required to make them as well as to just understand them, they deal a lot with perpendicular lines. So we just need to discuss parallel versus perpendicular lines. And because we're discussing it, the IB is like, well, it's content. We're going to give you IB type questions that deal with parallel versus perpendicular lines. We're building up all of this material to get to this really cool idea, which I'm almost 100% positive is going to be on your IB exam. The IB is super excited that they're now starting to teach you Voronoi diagrams, that I'm sure it's going to show up in an exam, or at least it'll be a really cool thing that you can do for an IA potentially. So let's go ahead and talk about parallel versus perpendicular lines. Parallel versus perpendicular lines, the main thing that you need to worry about or think about is just slope. If we're just talking about parallel versus perpendicular, it's all about the slope. So if you ever see something about like, oh, these lines are parallel, or oh, these lines are perpendicular, you know that you need to do something with the slope. And then the formula, not really a formula, just the thought is that the slope of one line, if it's parallel, is equal to the slope of the other line, which makes sense when you just take a second and think about it. That if two lines are parallel, that means that they're never touching, which means that their steepness will always be the exact same, because if one is more or less steep than the other, there's going to be a point of intersection at some point along those lines. So if you've got parallel lines, just all of those slopes need to be exactly the same. Versus, I've got terrible handwriting today, perpendicular. Your perpendicular lines are opposite, completely opposite, polar opposite slopes. Okay? So what that means is that your second slope is equal to the negative reciprocal of the first slope, which means if I were to say that, here's an example. If M1 is equal to 3, then your perpendicular slope, so M2, parentheses, this symbol means perpendicular, so you'll see me use it pretty frequently. So I'll normally say like perpendicular slope is equal to, if it's positive, it becomes negative. If it's 3, you can think of it as 3 over 1. So you just flip that fraction, negative 1 over 3. So if the original slope is 3, the perpendicular slope would be negative 1/3, the complete opposite, right? If the original slope is, let's call it negative 4/3, then the perpendicular slope is going to be, if it started out negative, it's then going to become positive, right? A negative of a negative then becomes positive. So it's positive, and then you just flip that fraction, 3 over 4. So 3 is a little bit tough because it's not in a fraction, so this idea of flipping the fraction is tough unless you remember that 3 is just 3 over 1, so then you just do 1 over 3. Okay, so that's it. Parallel versus perpendicular slopes. That's the main idea. Now, if we're trying to write equations and we're saying, okay, we want to find the gradient and the y-intercept of this guy, and we want to find a slope that's perpendicular, or an equation that's perpendicular to this guy, we take the slope and turn it into a perpendicular slope. And then we can create an equation of a line knowing that that's the slope we're looking at. So let's practice it. Find the gradient and the y-intercept of this line. This is a review of previous lessons, so go ahead and answer this. If you are struggling, move over to 3.2 and look at if this is y alone, if y is isolated, what is the gradient and the y-intercept? So if we're talking about y equals mx plus b, the number that is in front of x is your slope, not x, right? If you put x with your slope, it's wrong. Your slope is just the number that's in front of x. So m equals 3 over 5. Or 0.6 if you put it as a decimal. The y-intercept is this guy right here. I saw in some of your guys' quizzes recently that some of you were talking about the x-intercept as the b value here. That is not true. It is the y-intercept. So the y-intercept is a point, so I'm going to write it as 0, 2. Remember that if it's on your y-axis, your x value is 0. You didn't move left or right. You just stayed right there on that axis. So that's my y-intercept. Find the equation of a line that passes through this point and is parallel to the given line. If we're parallel to the given line, what can we say about the slopes? They are the same. Remember, if they're parallel, the slopes are the exact same. So I know that my new slope is going to be the exact same as the old slope. And then we know that my x1, y1 is going to be equal to 1, 5. So we were given a point, the point is 1, 5, and now we have our slope. Which form of the equation of the line should I use in order to start this? Since I have a point and a slope, I can use my point slope form to create the equation of this line. That is y minus y1 equals m times x minus x1. So that's going to be y minus 5 equals 3/5 times x minus 1. Now, I'd like to point out, it doesn't tell me what form of the equation of the line I should put it in. It doesn't tell me. So I could leave it exactly like that, and that would be the equation of the line. Typically, it will tell you to put the equation of the line in the form ax plus by equals c. And then it will say something along the lines of like, hey, a, b, and c exist as integers. It's like a fancy bolded z, which means it exists in the integers. So let's just practice putting it into that form. Integers are just your whole numbers, which means fractions are a no-go here. So I can distribute the 3/5 into each of these guys. Y minus 5 equals 3/5 x minus 3/5. If I wanted to put it into this form, and I don't want it to have a fraction, which is typically what the form you will be asked to give it in, I can always multiply by the denominator, right? If I multiplied every single term by 5, it would definitely cancel out the denominator of those fractions and they would just go away. So if you don't like a fraction, the number one thing you can do is just multiply by the denominator. If you multiply every single thing by that denominator, then it all goes away and there's no more fractions. You can even do this to solve if the answer still is going to be a fraction. If you don't want to manipulate equations with fractions in them, just multiply by the denominator and then continue to solve and isolate for y, and it'll all work out. Multiplying everything by 5 means I do 5 times y, means I do 5 times 5, means I do 3/5 times 5, which is 3, and 3/5 times 5, which is 3. Putting it into this form, a is positive, notice here, so I would keep my x on this side. I'm going to subtract 5y from both sides. So I get 3x minus 5y equals, and then I'm flipping it around, so bear with me. I've subtracted 5y over to here, and then I'm going to add 3 to be over here. So negative 25 plus 3 is going to be negative 22. Use your calculator if that's something that freaks you out. This is putting it into general form, something that we talked about in our last lesson. We used the point slope form in order to put it into the equation because we had a point and a slope. That's the logical place to put it in. You could not immediately jump to general form given this information. So we have to use this form to get to this final version of the form. Most IB questions will ask you to put it into this form, so it's good to get in the practice of putting it into that form. Okay. Find the equation of a line that passes through the point 1, 5 and is perpendicular to our given line. So if our original slope is 3/5, what is going to be our perpendicular slope? Since it starts off positive, our perpendicular slope is now going to be negative, and then the fraction just needs to flip. So it becomes negative 5/3. Our x1, y1 is still 1, 5. And we're still going to put it into our point slope form and then turn it into a general form. So y minus 5 equals negative 5/3 times x minus 1. I don't want to deal with fractions right now, so what I'm going to do is I'm going to multiply everything by 3. If you want to multiply everything by 3, it gets rid of all of these fractions. So then this becomes 3y minus 15 equals negative 5x plus 5. 3 times y, 3y. 5 times 3, 15. Negative 5/3 times 3. Negative 5, 5/3 times 3, 5. Just multiplied everything by 3. Now I want to put it into a form where a is positive, so I'm going to add 5x to both sides to make it positive. So it becomes 5x plus 3y, and then I want to move this 15 over here, so I add 15 to both sides because it's a negative 15, which means that I get equals 20. And there you go. That's the general idea of finding an equation of a line that is perpendicular or parallel to a given line, is that you just really deal with the slope, and that deals with the parallel versus perpendicular. And then you just need a point for this line to go through, and then you're able to solve. Okay, we have 2 more examples that we're going to get through today, and then you're done.